So we've been looking at this idea of expanding algebraic expressions, and expansion is just when I have a pair of brackets, okay, I multiply everything inside the bracket by everything outside. So if I expand 2 outside of x plus 3, that's just going to give me 2x plus 6. One way you can think of factorizing is it's working backwards, so it's working the other way. If I go from 2x plus 6 and introduce those brackets again, right, that is what you would call factorize. Okay? And what you've done is you've seen, okay, what's in common between these two terms? I've got 2x and I've got a 6. So I know 2 is common. So I can take that 2 out. I can take it out outside the brackets. And then whatever you take out, you want to divide that term by that amount. So 2x divided by 2, that's just x. And 6 divided by 2, that's just 3. Okay? That's a simple way of thinking about factorization. Okay. Let's have a look at some examples. Okay, so you want to look at these and you want to see, okay, what's in common between my two terms? So I've got a 3x and I've got a 12. Okay, I can see there's a common term of 3 there, so I'm going to take that 3 out. Okay, and so when I take it out, I want to divide this term by whatever I took out. So 3x divided by 3, it's just x. And 12 divided by 3, that's just 4. Okay, can you see how I'm taking it out and introduce some brackets? I'm going to do the same thing here. It doesn't matter what I'm taking out, if it's a number or a variable, I can still take that out. Y squared minus 2y. I can see there's a common factor of y there. Okay? So I'm going to take that out. And then I realize, okay, y squared divided by y, that's just y. Okay, and I'm dividing negative 2y by y, that's just 2. One way you can check really easily is if you expand these out, you will still get the same result. So we're not changing anything, we're just rewriting in different ways. Okay. Third example here. 5x plus 3, so 5 outside of x plus 3, plus 2y outside of x plus 3. So this is a bit more complicated than these examples here. But we can still apply the same idea. Right? What's in common? I can see that there's a factor of x plus 3 there. Okay? So I'm going to take that out first. Okay? And you remember, when I take something out, what I'm really doing is, I'm dividing this term by what I've taken out. So I've taken out an x plus 3. If I divide this whole term by x plus 3, all I'm doing is just removing those brackets there. So I just get left with 5. And this expression here, 2y outside of x plus 3, if I divide that by x plus 3, I just get left with 2y. Okay? That's simple factorization. Another way you can factorize is if you're grouping in pairs. When would you want to do that? If an expression has 4 terms, it can commonly be grouped into pairs. Okay, let's look at some examples. So 2x plus 8 plus bx plus 4b. Unfortunately, we can't do simple factorization here because there's nothing that's in common between all the terms. Okay, but what we can do is we can look at the two pairs and think, okay, is there anything in common between the pairs I have? So let's look at the first two. 2x plus 8. Okay, I know there's a factor of 2 there, so I'm going to take that out. I get left with x plus 4. And then, in the second one, I can see there's a common factor of b. So I take the b out. And then bx divided by b, that just leaves me with x. 4b divided by b, that just leaves me with 4. Okay? But then I notice something else. This looks very similar to this question over here, right? I look at these two terms. I've got 2 outside of x plus 4 and b outside of x plus 4. So what I can do is, I can take out that common factor again. So if I take out that common factor of x plus 4, on this side I get left with 2. And this term gets left with positive b. Okay. Let's take another example. ay plus a plus y plus 1. Okay. So again, there's nothing that's in common between all of the terms. So I realize that I've got 4 terms, so I want to try grouping in pairs. So let's look at the first group. ay plus a. Is there anything in common there? Yeah, there's a factor of a. So let's take that out. ay divided by a is just y. A divided by a is just 1. Now, when it comes to this term, y plus 1, there's not actually anything in common between them. But there actually is, because they both share a factor of 1. Okay. What do I mean by that? Well, if I take out a factor of 1 from these two terms here, right? If I take that out, if I factorize that out, and I write down the original terms, you notice how I haven't changed anything? I've taken out a factor of 1, okay, but if I expand it out, I'm going to get the same result. Okay? So that's a little trick I can use. From there it becomes really easy, because this looks something like that again. Okay? So I've got that common factor of y plus 1 here. So let's take out the y plus 1 from both terms. So y plus 1 on the outside. And inside, I've got left with a when I divide by y plus 1. And just a 1. Now let's look at one more example over here. So I've got 2x minus 4 plus 6y minus 3xy. Okay? So there's nothing in common between them all. Okay? So I want to think about how I can group them in pairs. So let's look at this first pair. I've got 2x minus 4. Let's take out that factor of 2. And then the second one. I want to think, okay, I've got a factor of 3 I can see and a factor of y. Let's take that out. So we've got 3y, because that's going to be 2, minus x. But now I've hit a bit of trouble, because this term is not the same as this term. So I can't take that same factor out in the same way I did before. But I can realize a little trick, because 2 minus x, okay, that's pretty close to x minus 2. But there's a difference, because this is just this expression multiplied by negative 1. Right? So what I can actually do, in the same way that I took out a factor of 1 in this question, I can take out a factor of negative 1 in this question. Let's see what we get. So I'm going to leave this one as it is, this first term. And I think, okay, what if I take out a factor of negative 1? Okay, well, then I'll just get minus 3y. And then these signs would change, because I'm dividing by negative 1. So I actually get left with x minus 2. And you can double check this by expanding out this expression. Okay, you should get the same answer. So I get 3y minus 3y multiplied by x, that's minus 3xy. And minus 3y multiplied by minus 2. And negative times negative gives me positive 6y. Okay? And then it's just like any other question. Okay? I can take out that factor of x minus 2 that's in common between the two terms. Okay? So x minus 2. On this term I get left with 2. And this term I get left with negative 3y. That's grouping in pairs.